Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnudat and I work as a network architect in Cisco. Let's discuss the agenda of this session. First of all, we would like to discuss what WAN actually is, and I want to make it really very basic. Okay? The basic means so that everybody can be on the same page. So in the starting few sessions, we will be explaining you the most basic concepts of software-defined WAN. So here is the agenda for this session. First of all, we will be discussing what WAN actually is with an example. Then it is always important to understand the history of WAN. And why I'm saying this? Because there is a gradual change in how WAN works from leased line to MPLS to SD-WAN now, right? And you would be really enjoying it. So the third point, basically, which we are going to discuss is, we will take an example of a traditional enterprise, how it looks, what are the various components of this, traditional enterprise, actually the architecture of a current enterprise, you can say, right? Now, once we understand the traditional enterprise, how it looks, we would be discussing about the problems in current enterprise, right? So if we understand the problem in current enterprise, we can appreciate more the importance of SD-WAN, right? Now, finally, we will be trying to resolve all these problems or challenges and then introduce SD-WAN. So all these sessions are going to be mix of theoretical portion, which will explain you the concepts, and hands-on lab. So I have recorded some of the hands-on lab also, and I will be releasing them soon. You will be having the recorded version of this session also. But it would be great if you can attend this in person. So with that, let's begin and try to understand actually what WAN is. Okay. So I have a company XYZ, and which is having its campus in Delhi, right? And as you can see that there are a number of laptops here, which means that we have employees also in our company. And suppose there are 100 employees, such employees. Company is just having a campus in certain part of India, which is say Delhi. So for my European friends who is part of the meeting from Europe, I will be taking most of the examples from India and places. So for your information, Delhi is the capital of India, and I have opened a company called XYZ there, right? So I have put one server also so that these guys can share files. Suppose this computer A wants to share file with computer B, right? He can put his file in the server and B can go and fetch that file. It's a simple file sharing application, right? Now, these employees also want to get connected to internet. So I have connected my enterprise to internet, right? And people are happy there. Now, as my company grows, I need to open its branches also, correct? So I have opened 2 branches first in Mumbai and the other one is Bangalore, correct? And now the problem arises. When a certain employee comes to branch at Mumbai and wants to take a file from this server, how it is going to get that file, right? And the problem is that he can get this file if this branch is connected to this company's main headquarters, which is the campus. So this is the problem which we are talking about, that any technology which you use to connect this remote branch to this campus comes under WAN, right? So anything which is filling the gaps here will be wide area network technology. And we have many. We have many, from simply connecting them over a cable, which is a leased line, to MPLS, to frame relay and whatnot, right? We are evolving in this matter. So right now, if you consider this company is XYZ, is headquarters in campus, want to connect to Mumbai and Bangalore branch, and they are connected over a leased line, right? So overall, if you can see that we want to talk about the wide area networking, and that's what all these technologies like leased line, MPLS comes under WAN. So now this is the time to discuss more about these technologies, right? I want to make this session a very basic session so that everyone who is out from the college to having several years of experience can understand whatever I am planning to explain here. So first two sessions, we are just going introduction about the WAN and how it is evolving and how SD-WAN is currently solving the legacy issues. Okay, so at a broad level, we understand WAN, that whenever we connect our remote sites, right, which are far away from us, to the main campus, we want something which is wide area network. Okay, so now let's discuss how this WAN has been evolving over the years. So I have the same thing. Now let's see what are the various mechanisms through which we can connect Delhi campus with Mumbai branch and Bangalore branch. First of all, when I want to connect my Mumbai branch to my company, I need to take services of service provider, right? So I go to service provider and I ask that I want to connect my remote branches to the campus. And they say that how many branches you have, right? So I have an answer for that. I have only 2 branches. My company is new and I just want to connect them. So service provider suggested me that you can take lease line, right? You just connect this guy with this over a cable, physical cable. And this is my responsibility. This is the responsibility of service provider to lay down this cable. Okay. Similarly, he's saying that you can connect your Delhi campus with Bangalore office also. And if you want, you can connect Mumbai office to your Bangalore also with the same lease line. But the cost of this lease line is really great, really too much, right? But what purpose it is actually solving? The purpose it is actually solving is, suppose I have an employee here, employee name is say A, and he is part of this network, say x.x.x.0/24, right? I have a server here, which is in the subnet, say y.y.y.y or 0/24. I can only be able to connect to this server if I know the route to reach to this server, right? It means that somehow I need to get this route y.y.y.y in Mumbai branch. If I see that, then basically my problem is solved, right? Because I will be able to reach to Delhi campus. Similarly, if Delhi campus want to reach to me, means Mumbai, they need to have this x.x.x.0/24 route. Correct? It is as simple as that. So how come this lease line is solving this problem? This lease line is going to connect to the router at both the ends, right? And I can configure an IP address here. If I configure an IP address, then this is the service provider responsibility so that I have a connectivity over this link, right? If I have the connectivity over this link, I can run any routing protocol from RIP to EIGRP to OSPF so that I can exchange my routes. And by the way, guys, although there is no prerequisite for this training, but it is great. It would be great, means if we can brush up some of the concept of OSPF or BGP before this, right? So if I have the connectivity between these 2 routers, maybe R1 and R2, I can run OSPF between them. And then obviously I can advertise this route from here and I can advertise y.y.y from here. And my problem is solved. These 2 guys will be having the necessary routes and the traffic flow would be like this, which is very simple to understand, right? So when we wanted to connect our WAN, when we wanted to connect our remote branches through WAN, through lease line, basically we can run a lease line, we can run a routing protocol over it, and then we can eventually send traffic over this lease line. But the problem with the lease line is that it was very costly. So here is the next solution which is provided by the service provider, which is frame relay. I do not want to talk much about frame relay because there is a new technology which offers better solution than frame relay, which is MPLS. Right? Now let's see how MPLS is resolving our issues of WAN connectivity. So for that, let me just remove all these things. Okay. So now let's discuss another technology which is solving the same problem, which is MPLS. Now MPLS service provider came to me that you can have the connectivity, your WAN connectivity in much lower prices, right? What he says that you just need to connect to me, right? Not to the remote branches. And I will make sure that your routes will be reached at the correct place. So again, here was my route, x.x.x.0/24. And for server, that was y.y.y.0/24. Correct? So service provider is saying that you place a router at your site. I will place a router at my site. Similarly here. Right? You use any protocol of your choice, maybe OSPF-BGP or whatever you would like to. Right? You share all of your routes to me, and I'll make sure that these routes will reach to correct places, like towards campus and towards Bangalore. Right? It's very simple. But do you think that MPLS service provider is going to develop this complete cloud just for me? It is not the case. Here with MPLS, many of other customers will be connected, right? But it is the responsibility of service provider to make sure that my routes are reaching to correct place. And if this cloud is able to distribute routes at correct place, then there is no problem at all. I can use this service provider network to reach to my campus or other branches, right? So the traffic flow in this case is going to be from, if someone from Mumbai branch wants to access the server, it will use the MPLS network and access the server. If someone wants to communicate from Mumbai to Bangalore, he will be using again the MPLS cloud and reaching to Bangalore. This is as simple as that. So I would suggest you to, if you want to read more about MPLS, it's a service provider technology whose job is to just take route from one customer and put it into the same customer's other branches and campus or the data center, right? It is as simple as that. But how this technology works, which label they use, it is very interesting to know. So if you are interested in further reading, please do that. But for SD-WAN purpose, for us, it is just a cloud which is capable of transporting our routes from one branch to other branch or from one branch to the campus or data center. That is it. So if you see how SD-WAN is evolving, how WAN is evolving, first we have leased line, then we have MPLS. But now there is a question, can we use internet to connect our branches? And the answer is yes, we can use internet, but there are slightly tweaked to that, right? There are slightly, what you can say, there are other things to notice when you connect your branches with campus. And what are those? Let's understand those also, okay? So let me remove the drawing and replace this MPLS with internet. So now we have internet, and as you guys know, that internet is basically a network of networks or network of interconnected networks, you can see. So here we have internet, and here we have many routers attached, right? Using many service providers. So I again went to the service provider. I asked him that I want to connect to internet so that I can connect to my campus and other sites. This guy went to, I went to the service provider, and service provider said that you need to connect to internet. And if you want that, I can give you an internet link of certain bandwidth. Okay, I went and asked. And by the way, guys, internet links are slightly cheaper as compared to MPLS, and that's why I am looking for a cheaper solutions now, right? So again, we need to place router here, we need to place router here and here. But the problem here is that although I can connect to from this guy to this guy over the internet, because service provider will be giving me an IP address, which is the public IP address, which is routable across the globe. So he will give me one IP address here, one IP address here, and of course here also. And all these IPs are reachable, right? And this is the responsibility of internet to provide reachability. But the problem is I cannot run a routing protocol from this router towards this router. And the reason is, if you have gone through some of the basics of routing, or especially interior gateway protocol, if we have two routers, say R1 and R2, and if I want to run, say, RIP, EIGRP, or OSPF between them across a link, then this link should be directly connected, right? This is the requirement from the IGP. And as you can see that this IP is not directly connected to this IP, and even you can see there are many routers which may be in the between, right? So I cannot run a routing protocol, basically IGP, although I can run BGP, but there are some problems associated with that too. But right now I cannot run IGP because these IPs are not on a single link, right? So what I need to do this to mitigate this issue, and that is where the next generation of WAN technologies comes into picture, which we call GRE and IPsec. So as I mentioned, that prerequisite of this video of this session is basically my own video which discuss about underlay, overlay, and GRE, right? So if you haven't gone through that, that is fine, because right now if we do not have a direct link between router 1, suppose this is router 1 and this is router 2, then what we can do is we can create a direct link over this internet. And that link is going to be the virtual link between R1 and R2, right? So as you know that we have the connectivity between this IP and this IP. Through this connectivity, I can create a virtual tunnel or virtual link. How this link look like, how the packet move across this link, basically we can discuss in later sessions, because this is really, really important to understand SD-WAN. Because there also we are going to create such kind of tunnels, right? So in GRE, just for right now, just assume this R1 is connected to R2 over this with this virtual link. Because this virtual link is formed over a physical infrastructure, we call this physical infrastructure, which is internet in this case, as underlay. And this virtual link, which is over this underlay, as overlay. Okay, this is very simple to understand. Now, when I say that I have a virtual link, which is as good as a direct point-to-point link between R1 and R2, I can now run my routing protocols here, right? I can run RIP, EIGRP, OSPF, whatever you want, and if I can run that routing information protocol, I can send whatever the route I have here, x.x.x.0, over this link. Correct? And definitely this guy will be receiving those routes, and then the connectivity is established between Mumbai branch and the campus. I think it makes sense. So the traffic would be like this, right? Similarly, I can make a GRE tunnel between Mumbai and Bangalore for a direct communication, right? But there is a problem. The problem is, as internet is publicly available, there are many eavesdroppers also, right? Which are ready to take your data when you send it over over internet. So how do we resolve this? And that is where security comes into picture, right? And this is where internet protocol security comes into picture. So This is again again very basics which we required for our SD-WAN learning, right? What we do in IPsec is whatever the packet which is going out from this Mumbai branch, there is going to be an IP packet. So what IPsec does, it will encrypt this packet with certain key value, so that only receiver, means only the campus, will be able to decrypt it, right? So this packet, the new packet, is going to be the IPsec packet. And don't worry, this is on a very high level view of IPsec, but we will going deeper when we are discussing the security portion of these sessions, where we will be explaining the public key infrastructure, certificate, and how IPsec works. Okay, for now, just try to understand nothing is going into plain text over internet when you encrypt it, right, using IPsec. So no eavesdropper can be able to see your packet, right? So that is where after GRE, which is a plain routing encapsulation, IPsec come into picture, and we say that we will be using GRE, but we use GRE or this tunnel in conjunction with IPsec so that we have a proper security mechanism so that nobody can take the data which is going over the internet, right? So if you consider history, first thing, leased lines, right guys, costly. Then frame relay, again costly. Now we are in the era of MPLS, where we are connecting our enterprises over MPLS. As MPLS is a private network developed by service provider, we do not need security here. But it doesn't mean that we can't configure security. Even over MPLS, there are many customers, almost all customers, which are using IPsec because they do not trust. They do not trust the public private MPLS cloud also. But of course, over internet, we need to make GRE tunnels, and then we need to make them secure using some protocol. And here I have taken the example of IP security protocol, which is IPsec. I think the things are making sense. Now, basically, we have discussed how actually the current infrastructure, current enterprise connect their remote branches to their main campus or data center. Now let's understand how a current enterprise or the legacy enterprise looks, right? We will understand the various architecture of an enterprise or maybe a legacy enterprise. Then we will discuss the problems associated with them. And believe me, if you understand the problems associated with the enterprises before SD-WAN, or basically or the customers which are using the legacy enterprise architecture, if you understand the problem in that, you will be appreciating more this SD-WAN solution. And believe me, if you understand the problems, half battle is done with respect to SD-WAN, understanding SD-WAN especially. Okay, so let's move and understand how an enterprise looks like. Okay, so here I am taking an example of a somewhat medium level enterprise, and that's why I haven't written my company here, which was XYZ. This is a bigger company and have several other branches in campus. And now there is a concept of data center also, right? Why we need data center? So previously, if you have noticed that I have put my servers in campus, right? That was a small enterprise. That is, for a small enterprise, that is fine. But when you have a lot of servers, a lot of applications, you don't want to put them in a place where you want to put them in a place which is closer to all the branches, right? So that is why basically you place all the servers into a particular place, right? Which is equidistant from your other branches. So that place is nothing but a data center. So data center is a place where you have put all your servers. When you were a small enterprise, you have put all the servers in the campus, but now you have taken out those servers and put them in a special place, and we call that a special place as data center. It is as easy to understand data center, right? Now, your applications, your server, your file server application, everything is in data center, right? you have campus, you have many other branches which will eventually use the services offered by this data center, or which want to consume the applications which are in data center, right? And again, to connect your campus branches to data center, you need WAN, you need wide area network. And that's why I have two technologies here, which is MPLS and internet, which are providing the connectivity from campus to data center. And we have discussed that how we can achieve this connectivity. MPLS is very, very simple. It just takes the routes from campus and data center and then place them basically and advertise to each other. Same thing according to branches also. Over the internet, we will make GRE tunnels or the tunnel and run a routing protocol, and then basically we will transfer our routes from one branch to other, right? So if you notice that in campus, I have both the technologies available as WAN, and we call them transport, right? So I have MPLS transport, I have internet transport in my campus. In my data center also, I have MPLS transport and internet transport. But as you notice that some of the branches doesn't have the luxury of having both MPLS and internet. Maybe it's a remote branch. Maybe there are people which are very less, right? There are employees which are very less in branch 3. So we do not want to give them a high value MPLS connection, but we just want to give them only internet. And these guys can connect to rest of the enterprise over the internet, right? But there are some branches you can see having both MPLS and internet connectivity, some branches which are having only MPLS connectivity. But the whole expectation is that every branch should be able to consume services in data centers. And it is up to the design of a particular enterprise how they want to communicate between branches. Whether there should be a communication between branch 1 or branch 2, it is up to the design of that enterprise. Generally, enterprises believe in hub and spoke model. So as you notice that all of the services, all of the servers are placed in data center, right? And everybody wants to consume services of data center. So generally, they make this data center as hub, and whatever your site, like campus, branches, and everything as spokes, right? And the idea is that hub is able to communicate with everyone, right? And if this spoke 1 wants to speak to spoke 2, there is not a direct connectivity between them. So this connectivity is not there. So how the traffic flows actually happen from S1 to S2, it goes to hub and come back to spoke 2. Similarly with spoke 3 also, right? So generally enterprise choose this model, and data center is the place where they want their hub is, and basically all these are spokes, right? But it is not the case that it is always the preferred model, hub and spoke model, because I have seen in my experience that there are many organizations who want the communication between their branches also, right? So this is generally how traditional enterprise look like. Here I would like to tell you one more thing, that suppose if this guy here, this laptop wants to reach internet, right? Company security policy says that you need to go via firewall, and mostly the firewall is a costly device. That's why they have put many firewalls in data center. So the actual firewall, if you need a security, so the actual traffic flow from this device, this laptop to internet, it should be via firewall because you need security, right? So if you see, I'm drawing a traffic pattern from this laptop towards internet. So first it will go to MPLS, it will reach to data center. In data center, we have firewall, which will be putting security policies on this traffic flow. It will come to this again edge and then move out of the internet, right? You must be thinking that this is this is not the flow which we want, because internet is directly connected to this campus, right? Why do I want to go to data center and then go to internet? But this is the case. This is actually have been happening from last several years, because we have only one point of security policy insertion. That's why we are going from campus to data center, passing everything through firewall and then go to internet. I totally agree with you guys that this is the it is not the optimal path to reach internet, but this is the case what we are facing right now. And definitely we will be explaining in upcoming slides that this is one of the problem which SD-WAN is solving, right? It first, and I believe explanatory. This is very simple to understand. Now, let's see what are the problems associated with current or legacy enterprises, and let's discuss. As you can see that everything is same in this new diagram, but I have put this cloud here, right? And of course, I need to put it because since last decade, you can say, there is a lot of change in WAN infrastructure. There is a lot of change in how we consume data center services, right? Nowadays, the application even doesn't reside in your private data center because it is very, very hard and it is very, very costly to manage your data center, right? So generally what companies are doing, they are moving their applications from data center towards public cloud here. As you can see previously, this Office 360 Dropbox used to run in data center is moving out from data center, private data center to public cloud, right? And that is why I have put this cloud here. Moreover, actually, if you consider the devices which were using the services of this data center or cloud are changing. Previously, we had only laptop, desktop. Now we have mobile devices also. We have mobile devices, iPad, and whatnot, right? So the way we are consuming data center, the way we are consuming the application is totally changed now. And believe me, the architecture of a common or legacy enterprise remains same, just like this. And of course, it is not meeting the requirement, and that is why we are having the new technologies, right? So now I would like to explain you what are the various challenges, what are the various problems which are in current in legacy enterprises, right? So first one is application performance, right? Suppose there is one app running here, say app 1, and one app is running here, say Office 360. I will take first example of Office 360, right? So, and this guy A wants to access or consume this application. As I mentioned, the current flow is not optimal. If we do not do anything, the current flow is going to be this guy will go to MPLS, this guy will go to data center. It needs to pass through firewall, then it will go to internet, and then it will consume the services of cloud, right? There are many applications which are time sensitive, right? And the application performance will be degraded if we choose this longer path, right? This path is perfectly fine if we go back 10 years back, right? We did not had cloud at that point of time, but now we have. So what should be the optimal path? The optimal path should be if we can go directly over this internet and consume the cloud, right? So right now, basically, if you are in a legacy model of your enterprise and you are using legacy WAN, everybody is facing this problem that their application are not optimal. Their application are showing several issues because there is a packet loss, there is a delay, and some application just cannot work at all if there is jitter and delay in the path, right? So the first problem which this current enterprise are seeing is application performance. The second thing is cloud connectivity, right? Definitely, if I have a direct connectivity of internet from this branch, why I am going again to data center and coming back to cloud, right? Cloud presence is everywhere. Cloud presence is everywhere. I have noticed there was one question that what about the security, and I will be dealing with that. That is going to be the third point. So don't worry. But it's a nice question. So cloud connectivity. As you know that cloud is present everywhere. If you see the AWS, they have many regions in which they have their data centers. Suppose this branch is in Mumbai branch, and we have a local cloud presence there. Why do I need to go even the data center and to connect to the cloud, which is really very close to me? And yes, there are security concerns if I connect to, and that is why these new products are meeting those security constraints. And we will be discussing all these security challenges and how we can mitigate it through SD-WAN in upcoming sessions. But yes, the question is valid. We do have security problems, but we can be able to resolve them using SD-WAN. And how we are doing that? Definitely, I will be covering those in upcoming sessions. Of course, this direct internet access. Again, the question is same. I do not need to go to data center for accessing the internet. If I have a direct internet breakout, I should go and choose it there. So all of these four challenges are somewhere related to not having optimal path towards the cloud, right, or data center, right? So there is another problem. Suppose sometimes we have seen that if we have a very good internet link and we have a link which is very less bandwidth of MPLS, sometimes we have seen that internet link is performing much better as compared to MPLS. Now, other problem I would say is that again, suppose this guy wants to, this guy A or B wants to consume an application which is here, this one, application 1, right? Right now, to me, this MPLS path is better in terms of say latency and jitter. There is no drop over this link, right? So what everybody will be doing is it will be choosing this path, and I'll draw this path from green color. Maybe take another pen. We will be choosing this path to consume this application, and we are very happy. Currently, generally. In legacy enterprises, customer use this as a active link, the MPLS, because it is more reliable as compared to internet. So this is active and this is passive link or backup link, you can say. Mostly we were using MPLS. But what if there is a problem in service provider network, right? Suppose now this MPLS having more than 6% of packet loss. It is not the case. It is going to have, but I'm just taking a hypothetical example in which the MPLS link is having much more packet loss, right? So the problem is I cannot use this backup path because I have configured it to do so, right? This is only the backup. Once my active goes down, I will be having the backup. So instead of having a better link, which is having less packet drops, I was still using the MPLS one. And this is where little bit of dynamism should come into the picture. There must be somebody who can track all these links availability in terms of packet loss, latency, and jitter. And if we find a better one, it doesn't matter whether this link is down or this link is down, everybody should be up, every link should be up. And if we find a path which is better over this link, then we should be able to go over this instead of this. Right now in current legacy enterprises, we cannot even think of it because everything is active backup, right? Even if MPLS link is not performing well, we have to use it, right? So there must be someone who can look at from the top that whether which link is active, which link is performing better, and if this link is performing better, I should move my app 1 traffic towards this link instead of again using the same old one. right? And this is what we call application performance or application experience. If we can do that, then we will be having greater experience, rich experience for that particular application, right? The other challenges which I have put down, deployment and management, these are very serious challenges, guys. Suppose I want to have other branches, maybe 20, 30 more branches in my organization. This takes time, and previously every site needs 1 or 2 days to implement. Do we really require that much of time? This is a question. And definitely, this is another challenge which we feel, which we face in legacy enterprises. The other one is management challenge. Suppose if we are okay with every other problem, then do we have a single pane of glass from which we manage everything corresponding to WAN, right? Maybe somebody has written automation around it. We have few products around that, but those are not that much capable of what SD-WAN can do, right? So right now we came across all these problems, all these issues which are there in legacy enterprises. If we can solve them, if any technology can solve them, then definitely that is good to look at, right? And believe me, guys, SD-WAN is solving all these issues, all of them, in a structured manner, in a manner which is easy to understand. And now let's see how SD-WAN is solving all of these. So again, I'm using the same topology, but now this time we would like to understand how these issues could be resolved, right? I won't take the name of SD-WAN for now, right? Let's think around it. Let's think around it first, that how application performance can be improved, how cloud connectivity can be improved. Is there any way to secure my traffic if I directly connected from branch to internet, right? Is there any way to mitigate deployment challenges, which are really, really great? Is there a way so that I can manage everything from a single pane of glass, right? So what was my problem in case of application performance? I was not able to figure out that this link is now not working well. And on the contrary, this link is working well, right? If I compare both of them, that this link is optimal, and I need to transfer my application traffic from this link to this link, right? It would be great. It would be great if somebody from the top is looking on all these links performance, and continuously informing us about it. Or maybe it shouldn't inform us, but take the necessary action. So this guy will see that this link is not optimal. This link is optimal. And this guy will change the routing table of this campus edge router, this router, maybe router 1, so that now your traffic should be moving from this link. From this link. Just wait a minute, guys. From this link instead of going over MPLS. Very simple, right? And believe me, we have someone in SD-WAN solution. Mostly we call it a vSmart, right? Do not go into the terminology, and we will be discussing them in later. But think that yes, there is somebody who is looking from the top, who has a pretty good view of our entire topology and can make routing adjustment in all these devices, so that the optimal path is always taken, right? Does it make sense to have someone like this? Of course, yes. So now the question comes with the cloud connectivity and the security. Just wait a minute, guys. So someone has asked that if branch 5 directly connected with internet instead of going through data center, how we can make sure that there is enough security for it? Okay. So for your information, we cannot put firewall in every branch, right? As I mentioned here. Otherwise, it is going to be costly solution. So what we have done is, if you consider SD-WAN, we have put almost all the functionality of firewall in this device itself. This is SD-WAN device. So we have put almost everything, whatever a standard firewall does, into this SD-WAN device. So what are the security challenges which we had previously? We are not having them now. Apart from that, this guy is capable enough to know that what traffic should go out of internet directly and what should be routed through data center and go to internet or the cloud. Right? Again, this is an intelligent device. And why it is intelligent? Because there is someone who is looking from the top, this one, that yes, from here, this application from here could go this way. So I will be covering the deployment and management challenges and everything, and I will introduce SD-WAN, how basically vSmart, vManage, and everything work so that we can achieve, we can resolve all these issues. As right now we are already top of an hour, and I know that there are many people who will be having their meeting schedule lineup. So what I will do is, I will cover the remaining things like how SD-WAN is going to resolve all these problems, and we will introduce the SD-WAN devices and how actually SD-WAN works in next session. So when you come to the next session, means tomorrow, just try to have a look at this, look at the recording. Just try to think how MPLS works, how internet works, what is the architecture of current or legacy enterprises, and how we can resolve the problems of it, right? If you come with that mindset, then basically SD-WAN will make much more sense to you. So for now, I am stopping sharing my screen, and I'll ask you, I will be here for next 15-20 minutes. If you have questions, then please do ask directly. Okay. But once again, thanks for joining this session, and I really appreciate this. We'll try to make it better by putting everyone on mute, right? Otherwise, this is going to be a messy session. So it's all up to you guys. Shoot your questions, and I am ready to answer. Punish, Saurabh, if there is any question which I can take now, which you have noticed.
Yeah, Vishnu. So Ananta has asked, what is the actual difference between MPLS cloud and internet? So what he says that, like, I tried to answer that question, that MPLS is being the service provider which provides the services which can link the DC and the branches. It will be expensive since it will be reliable enough. And internet, on the other hand, it's not reliable, as we said. But what he's asking, yes, but actually the internet, we generally call MPLS also the service providers, right? The internet service provider.
Yes.
So how can we distinguish that?
Okay, so who has asked this question?
Ananta.
Hi Ananta, it's really a very good question actually. So the major difference between internet and MPLS is that MPLS is a private cloud, right? It is under the jurisdiction of one service provider, say Airtel. So Airtel has its own network which he has opened for his own customers, right? Customer 1, customer 2, many customers. But if you consider internet, right? I was talking about MPLS here. It is a public cloud, you can say. But if you consider internet, on the other hand, it is not under the jurisdiction of any single service provider. Many service providers are connected with each other to provide the service. And that is where you lose visibility when traffic moves from one service provider towards another service provider, right? So on a broader term, MPLS is private, internet is publicly open to everybody, right? And that's why there are more eavesdroppers there. And here, everything is under the control of a service provider. You don't see many. Punish, Saurabh, any other questions which I can take?
Nothing from, like, I did not get any personal question, but I think that's it from my side. Yeah.
If you don't have any other questions, let's discuss various nitty-gritties of SD-WAN tomorrow at the same time. Take care. Bye for now.